Hello everyone, welcome to this session. At the end of the session, you will be able to know about what is Hadoop distributed file system design, real-time examples, what is exactly the HDFS concept, so how the file system will be. So what is Hadoop? So I already told that Hadoop is two kind of components. So one is HDFS, that is Hadoop Distributed File System, and another one is MapReduce. So what is the HDFS? It's mainly handling for storage and manage the data in Hadoop cluster. So once store the data, process the data by MapReduce concept. It's founded on 2006. It's the open source. It is developed by the Apache. So they will call the another name is Yellow Stuffed Toy Elephant. It's mainly useful for store and process huge volume of big data in an efficient manner. So what is the real-time example of HDFS? So we will take one example. For example, phone number of everyone in the United States. So I have to store the name starting with A. So how we will store? So instead of storing on a single server, so we are storing in the server 1, that is the name start with A. So name start with B on server 2, so on. So with the help of Hadoop, so piece of this phone book would be stored across the cluster. So and easily we can reconstruct the entire phone book. So your program would need the blocks from every server in the clusters. So whenever the server fails, so HDFS replicate the small piece on 2 additional servers by default. So this offers multiple benefits, mainly for higher availability of the data. So that redundancy can be increased or decreased based on the per files basis. So it does not need any data redundancy typically. The redundancy also allows a Hadoop cluster to break down or break up the work into small chunks and run those jobs on all the servers in the cluster for better scalability. So finally, you gain the benefit of data locality with the critical when working with the large data sets. So hope you are understand. Instead of storing in the single place, so we are storing into multiple places. So that we can say clusters. So whenever the data is very huge. So take this Hadoop daemons, that is the design of Hadoop. So Hadoop made up of cluster with 2 nodes. So look the diagram. One is the master node. So another nodes that's we can say slave node. So what is the master node? So that's the responsible for name node. So it's having the job tracker daemons. It's mainly backend running process on Ubuntu machine. The next node we are going to see about slave node. It's mainly responsible for data node. It's having task tracker. So what is the use of this master node? That is, we can say that name node is responsible for storage. So job tracker and task tracker, so mainly for processing. So whenever we have the single node clusters, then it will be single name node, that is single job tracker configured in a single machine. Similarly, data node and task tracker configured in different machines. So look, so we have different slave nodes, and each slave node we have the task tracker. So it's looking like as a one single system. So it's running more than one system at the same time. So it's look like a master slave architecture. So name node, that is metadata storage. So mainly track for all the file in the HDFS. So all the information stored in the 1 GB RAM. So hope you are understand. So two parts. It is the master node and slave node. So master node mainly handling for storage, and that slave nodes are responsible for the processing. So what is HDFS exactly? So HDFS stands for Hadoop Distributed File Systems, mainly for storage unit of Hadoop. So I told two parts, one is HDFS, another one is processing. So and one more, the sub process is yarn. So what is the full form of yarn? Yet another resource negotiator. It's mainly used for handling the resource management. So what is the concept behind in this? So name node, data node. So we will see what is first of all name node. It is the master node. So maintains mainly the storage things and manage the data nodes. That's mainly handling the slaves. So how it's stored? It stored the records in the metadata of all the blocks of the clusters. So it's handling the information of, so what is the location of the blocks, how its blocks are stored, what is the size of the files, what is the hierarchy, so what is the permission is required for to get the data. So these are the informations are stored in this name node. So whenever any changes take place in the file system or metadata, that is also recorded in the name node. Suppose if any files is deleted in HDFS, so name node will immediately record in the edit log. So log is storing the data, updating the informations. So I can say this is the heartbeat of regularly receive the informations and the reports from the data node to ensure the data node is live or not. And maintain mainly the records of all the blocks in HDFS. So whenever the data nodes which they are stored. So what is the data node? So data node stores and receives as instructed by the name node. So mainly run each slave machines. The actual data where it is stored. For example, I told one example, that is the American phone book. So exactly the phone numbers are stored in every data nodes. So from this we can get back it through the whole phone book systems. So this is the responsible for serving read and write requests from the clients. And one more, the special thing is data node stores multiple copies of each file. So not only that, it's periodically report to the name node about, so what is the list of files it's stored, what is the status of the current data nodes. As well as it's responsible for creating the blocks, deleting the blocks, and replicating the same based on the decisions taken by the name node. As I said already, it's in the heartbeats to the name. So periodically updating the report, the health of the HDFS, and frequently it's set to 3 seconds. As I said, actual data, it's reside in data node. So what is the HDFS? The thing is name node, data node, we discussed things. So all the data nodes send a hot message to the name node every 3 seconds. So about the data nodes are alive or not. Suppose if the name node does not receive the heartbeat from the data node for 10 minutes, so it will consider in the state of dead states are out of space. So then it will make, so wherever the replication will be there, so that particular data node to be hosted on the same as a data node. So the data node talk each other. So to rebalance the data and move and copy the data around, keep the replications high. So when the data node stores the block of information, it's made in checksums also. So checksums mainly for handling the errors. So suppose any incorrect of the block is there. So any maybe corruption has happened, maybe data are corrupted. So that information informed to the name node. Okay, so aware of how that corruptions of data. So how we can take that steps accordingly with the help of the error correction methods. Sometimes the name node also crashed. Okay, so that is the metadata is crashed. So we are taking the data from the secondary disk, then all the transaction to present edit log. So what are the different the file systems? So one is the local file systems, Hadoop distributed file system, HFT, that is the HTTP based file system of Hadoop, HSFTP, HAR, HAR, KFS, Cloud Store, FTP, S3 block based. So these are the different file systems. So mainly the local file systems connected with the disk and client-side checksum. And HDFS already we discussed, that is for Hadoop distributed file systems and for two things. One is name node and data node. So mainly for storage and processing unit. So HFT is mainly provided with over the HTTP protocols. Okay, it's read-only access of the HDFS. And HSFTPs provide again, that is a secure system, HTTPS, that is a secure protocol systems on the web based. And HAR file system mainly used for reduce the memory usage of name nodes, as well as the registry files in the Hadoop's HDFS. And I have to talk about KFS, that is the Cosmos file systems. It's written in C++. So mainly handling of the file system in the Google file system, or that is a cloud store we can say. So FTP file systems, it's supported for mainly the FTP servers, file transfer protocols. So Amazon's, that's backed the file system as S3, that is the native systems. And we have one more, the Amazon S3, that is it's a limited, that is the 5G file limited, that is the block-based file systems. So summary of the sessions, in the session you have learned about what is the Hadoop distributed file system design, and what is the concept and what are the different file systems in this Hadoop. So now quiz time. So HDFS works in here, what is the fashion? So worker master, master slave, master worker, or slave masters. Let's check the answer. It's a master slave. So we are saying that is the name node and data node. So for every node in a cluster, there will be a data node, or name node, or block, or none of this. So as I said, we have two parts. One is name node, another one is data node. So data node, we are using that is a normal, our commodity hardware system. Okay, it's joined together, it's working as a clustered manner. So what is the answer? It will be data node. Thank you.